Okay, Bella, today I'm going to show you how to graph a linear inequality. And this is the last thing that we'll be studying before the midterm. And this also sort of wraps up our study of inequalities. So goals for today, one, find solutions to linear inequalities. In other words, it's an inequality that contains two variables. So we're going to be going back to x and y, just like we did with equations. And then this really here is what we're going to be doing for the most part, is graph linear inequalities in the coordinate plane. So if you recall, right, when we studied slope-intercept form, we just did our chapter a couple weeks ago on functions, we got really familiar with this format of equation, right? This is like an equation in slope-intercept form. And like it says here, recall that equations in slope-intercept form can be represented by a linear graph in the coordinate plane. So for this in blue over here, this y equals 2x plus 1, I have this line graphed for us. You can see it has a slope of 2 and a y-intercept of 1. As you can see right here, it hits the y-axis at positive 1, and then it goes up 2, right, 1, that's where you get the slope of positive 2. So when we were studying this, right, we learned that all points that fall on the line, which there are infinitely many, are solutions to this equation. You could take any of those ordered pairs that fall on the line, substitute them for x and y, and it would make a true statement. And we're really doing something very similar today, except instead of seeing an equal sign, you're going to see an inequality sign. But that does mean that there's going to be a lot more solutions than we're used to seeing. Instead of just points being on the line, we're going to be finding all of the ordered pairs that are greater when every time a y value is greater than an x value. So we'll get to that part in just a second. This first part is going to feel like review. We're just going to be graphing this in slope-intercept form. So even though this is a linear inequality, not a linear equation, it graphs the exact same way. This is a y-intercept of -3. So I'll use red for this. Let's just find -3 on the y-axis. 1, 2, 3. And there we go. Now the slope is positive 0.5. That's just another way of saying positive 1/2. So we go up 1, right 2, up 1, right 2, up 1, right 2. I'll go the other way, down 1, left 2, down 1, left 2. And then, once we have a bunch of points here, I'll graph my line. So that's just going to look sort of like this. See if I can make that red for us. All right. Okay, there we go. Now, we're not done, though, here, because in this situation, we have all the solutions that fall on the line, but there are a lot more possibilities because this is a greater than or equal to, not just an equal to. So I'm going to teach you the standard way to do this next part, and then I'll also show you a shortcut. I need to find a region in this coordinate plane that contains all of the solutions to this inequality. And the way you typically do that is you test the origin. So we're going to type, I'm going to plug in a 0 for x and a 0 for y. We test the origin, and we're going to see whether or not we get a true statement. So the origin's easy to use because 0 is easy numbers to work with, right? So let's see what happens here. If I do 0 is greater than or equal to, one second, greater than or equal to 0.5 times 0 minus 3. Okay, we go ahead and solve that. So now this is just going to be, okay, if I keep going here, I'm going to get 0 is greater than or equal to -3, because this just drops out right here. Well, ask yourself if that's true, right? Is 0 greater than or equal to -3? Well, you bet it is. So that's our that proves where our answers lie. What this is saying is since the origin is an answer, sorry, I'm having technical difficulties here. Since the origin is an answer, so will every ordered pair that falls on the same side of the line as the origin. So here's our line, right? You can ignore the blue one for now. Here is the linear equality that we just graphed. Y equals 1/2 x minus 3. We tested the origin. The origin is a solution. And that means we don't have to do any more testing. Every ordered pair that falls on that same side of the line, in this case above the line, is also a solution. Now, how do we represent this? Well, if you had a pencil, you would just shade this region of the graph. I'll do it kind of sloppy here. I am just going to shade, I know that looks terrible, sorry, but I'm just going to shade 1/2 of the coordinate plane. So if you were doing this on graph paper, you would literally just color in the half of the graph that contains all of the ordered pairs that make this statement true. Now, before we wrap up here, let's say for sake of argument, let's say this weren't true. What if we got something like 0 is greater than or equal to 1? Well, if that were the case, all that would mean is that we disproved this side, and that all of the solutions would then lie on the other side of the line. So we're going to do a bunch of practice with this today. It's really just as simple as testing an answer and shading that side. I'll tell you one thing, there's also another shortcut. I'll explain this more when we meet today. But whenever you see a greater than sign, you're going to shade above the line. If you see a less than sign, you're going to shade below the line. But more on that later. This is enough information for now. See you soon.